Hey friends, welcome back to the channel. I'm out in sunny Southern California. It is 68 degrees Fahrenheit, 20 degrees Celsius. Fantastic weather. I'm out here for the whole week for work, and I thought I would do a little bit of work on our LLVM backed compiler. So let's jump right in. Well, in the last video, we worked on our little LLVM backed compiler, and we got it to the point where we can type. We can run puts and a number and puts and a string like so, and it dutifully emits the LLVM IR, and it prints out those two things to the screen, and works really neat, and it was a lot of fun figuring that out. So in this video, I want to take it another step. I want to add variables. We only have one scope. We don't have function calls or anything else, so there's not a lot to do here. I think LLVM is going to help us out quite a bit, so we'll see how that goes. But before we get to that, I want to do a little bit of housekeeping. So why don't I open up our source, LLVM, and what do I want to do? First off, I want to get rid of all of these function pointers that I was passing in. These can just be globals. I don't know why I didn't do that to start with. Just didn't occur to me for some reason, but that's okay. We can just clean this up a little bit, and then that means we don't need to pass them here, and we don't need to pass them here, and we don't need to pass them here. And we just need to define these. I believe I could just take the auto keyword off of those and that one, and those are three functions, and let's just make sure that works. Rake LLVM and then LLVM, yeah, make sure I didn't break anything before we move on, so that looks good. Let's do a git add. I had to do some other thing. I'm just going to add all of it. Okay, so that's good. That's pretty easy housekeeping. The other thing I want to do is towards the end of the video last time, we added this if statement here. So inside of the puts generating code, we get the type of the value that's being passed to it, and if it's an int8 pointer type, then we assume it's a string. I don't want to make that assumption. I want to have a special type for that, and I was looking, there might be a better way to do this, I'm not sure. But one way I think that we could do it is with a struct type, and we'll just put one thing in the struct. So we'll call, where is it? So we'll call create, and create our own struct type, and then we will call set body, this set body right here, with one element in it, and hopefully I can explain that. So essentially what I want to do, if this was C or C++, I would say struct string, and then inside of that, this would be like a const char pointer stir. Okay, so that's what we're going to do, but in LLVM, and I think the way that you do that is struct type pointer, we'll call ours string type, and we'll make that global, but then we'll define it down here somewhere. Define our string type. I mean, that seems kind of obvious. This comment might be obvious. String type is struct type create, and what we pass is the context and a name. We'll give it a name, string, and then we need to set the body on that. String type set body. Yeah, that seems like that should work. It is not auto-completing though. Set body array ref type elements bool is packed. Okay, I don't know why my autocomplete's not working, but let's just try this. Array ref type star. This is capital, and then our type is IEP, and we will just move this up here. So I'd like to see why that won't compile. Hopefully that error message will help me out a little bit. Oh, I thought I fixed that. I keep typing a lowercase t on that. Is that why it wasn't happy with me? Possibly. Yeah, look at that. Okay. And then some of these functions we want to change. So instead of this return type of I8P here, I want to say this returns a string type. And then down here, instead of taking an I8P, I want to say this takes a string type. Okay, and then up here, I'm going to say if this type is a string type, then we're going to do that. And we get to see if everything still works, or if I missed something. It still works. Awesome. And now we can see that we have this string type, and all it is a struct that wraps a single type. And so assuming there's no padding or really any overhead, if this is a zero overhead data type, like a composite data type, then I think that we can just treat this, any string pointer, as an I8 star, I8 pointer, or whatever, and interchangeably. I don't know if it seems to be working. I mean, if this is not the best way, maybe there's like a better way to alias one type to another. But as long as this works, then I'll probably just go with this. But if you know of a better way, let me know in the comments. Definitely, I want to do things the right way. I can get rid of that comment and then add everything. Okay, that's all the housekeeping I wanted to do. I think I still don't know what to do here. So if there's a block with no elements in it, what do we want last result to return? Some sort of nil value, which we don't have yet. So maybe if we ever have a nil, I don't know what to do with this. Kind of feel like maybe this should just raise an error. If you get a block that has nothing in it, then maybe we raise an error. I don't know. So that's I'm just going to keep that fix me for now. So let's get to variables. I wanted to show you a blog article that I found by Makul. Sorry if I'm saying your name wrong, but this was very helpful for me. It is a little bit outdated, but it talks about stack allocation, and talks about how you can allocate space on the stack for a type and then store something in that and then load it back out. So this is what the IR will look like that we're emitting. But this is how you do it in C++. So I'm just going to copy all that code and do something with variables. Actually, first I want to space all these out. Space them out. Give myself some room here. And then the other thing we want to do is bin LLVM. What if I say x equals 3? I don't know how to handle node type 3. So if we open up node HPP, and we look at that type, it's an assignment. So we want a case statement for assignment. Assignment, and close that curly brace, and we want to do something. What do we want to do? I guess let's just paste in that code and get rid of kind of this comment right here, and don't need that, and we'll comment this out. We might need this later, but we don't need it right this second. So our first thing we want is, let's call this alloc A, just so I know what's going on, and that's a dot, and this type is some sort of type. What is the type, right? And then this is going to be a name. So those are the two things we need to figure out right now. The assignment, let's go look at assignment node. what does it have? It has an identifier and a value, so we don't even have accessors for those. Let's add those. Identifier return m identifier, and then the same thing for this is going to be value and value. So how do we do identifier node? But sometimes that's not an identifier node, so I guess I need to do an assertion. So let's do this. Let's say, come on, indentation. Auto assignment node is static cast. Natalie assignment node star node, like that, and then auto identifier is assignment node identifier. And then assert identifier type is Natalie node type identifier. It's a lot of colons. And then we want an auto identifier node is also static cast that Natalie identifier node start identifier. Okay, all that out of the way. Now we have what we need, I believe. And this can be name as identifier node name. So we have the name. Now we just need the type. We get the type from LLVM itself. And the way we do that is we need to walk tree of the node. The node is the assignment node value, and this I need to pass in the builder, I believe. That's the value, and the type for that is going to be value.getType. So whatever it returns, just ask it what type it is, and we'll use it that way. What user declare context? Maybe I just need to save it. What are you complaining about? No matching. Let's see. Did I do this wrong? Okay, so value get type, and then the next. Come on, that's not helpful. I guess it's because we don't really want an array size here. Null putter. And then the name. Okay, so let's put this back. Let's say null putter, and then the name is name. And so that's what I was saying. The blog is a little bit outdated, but it's pretty close. So why are you complaining now? I think that's going to go away in a second. And so we want to return. Oh, well, first we want to store something. So let's put this up here. Builder, and I think we can return this. Builder create store. The value is value, and the pointer is alloc a. Hopefully that's right. So now we have the assignment. What? During it's never read. Okay, I bet it is. Okay, so rake LLVM. Let's run that. Okay, so did it emit something? Yes, it did. It emitted this %x is it's going to store the pointer to the allocation in %x, and then we're storing something into that the memory pointed to by that register, and yeah, that works great. So that's the first half. Now we need the second half, which is puts x, and so it's going to say I don't know how to handle node type 23. Node type 23 down is identifier. Well, we kind of know how to work with identifiers, don't we? Let's copy all of that, get rid of that. Identifier we'll put down here. We'll say identifier. We'll just do that right there. This is a node. And then the identifier has a name. It, what do we need here? We need this load builder.createLoad, and we need that alloc A. We need to get it somehow. And how do we get it? Well, we need to store it somewhere. Probably the easiest way would be to use a hash map. So we'll just include our hash map implementation. You could use the standard library one, but I like using ours. Hash map type, let's say const char pointer, come on. And the value is, what is it? Oh, look at that. So it's right there. Alloc A inst, alloc A instruction, alloc A instruction pointer, and we'll call this vars. And I'm gonna need this again here pretty soon. So walk tree, it needs to pass in the vars here and the vars here and the vars right here. Anywhere else? Okay. And then when we call it, we need to pass it in. So let's go ahead and build this here, and our hash map, the way it works is you can pass in the type, which is a string type, which changes how the keys are indexed. So we want to call Natalie hash type string like that. Pass in the vars, go back up to here. We need to store vars, put, this needs to be a reference. We don't want to make a copy of that. That would stink. Put name alloc A. So let's store the alloc A in our variables hash map, and then down here we can get it back out. Auto alloc A is vars.get name. And so if we have an alloc A in the hash map, then do something. If we don't, then do something else. So printf variable not defined, %s, something like that. Name abort. This is a compile time error because we don't know what to do with that. And then if we do have an alloc A, then we're going to call and return builder create load. Create load is deprecated. Use the version. Okay, so we need to, that's where we need to use this get allocated type. So we want to return the type of the allocation. So alloc A get allocated type, and then the alloc A itself, and then we can give it a name. Let's just give it that name there, and see what happens. See what happens. Does it work? It does! Oh, that's so cool. X is alloc A, store the value, x1. Interesting. It does the work of appending a number to make it unique. It won't overwrite an existing register. It just creates a new one. So that's kind of cool. So it calls a load with that same type. Actually, this is the type, and this is the pointer to the storage, I believe. And then we call printf with that x1 register, which is a pointer. No, it's not a pointer. It's the actual value. Yeah, because it's just an I64. Oh, okay, that's cool. Cool. Does it work with strings? Puts y. It does. Okay, y is allocate. We're allocating a string type. We're storing the %1 string in that pointer, in that pointed to memory address. Then we're loading it back out, and I assume that this also works if I put things out of order. I sure would hope so. And That still works, right? Okay, what happens if this is an X and this is an X? What do we get? Oh, well, let's put this back in the other order. So if I put X, oh, semicolon, puts X, what's happening? So here we are creating an X2. It is a different register and it's a different memory location. So even though it kind of looks like, just if you were just to look at this code, you would assume that we're storing a 3 in X and then we're overriding that with a string in X. But what's really happening is we're storing both, and then we kind of lose that alloc A, we lose that allocation instruction because of how we're storing it in the hash map. So, I mean, this is where we get to decide. This is just a toy compiler, so I think I'll leave it for now, but we could decide to right here to say if vars.get name, if it already exists, then I'm not going to write the code, but like say if the type is different, raise an error. If the type is the same, overwrite. Overwrite? No, if the type is the same, do nothing. We'll just reuse the same allocation. So that we just get to decide how we want to do the semantics. I think for now, just leave this because I think that's kind of neat to kind of see how this is working. But man, this is actually coming together. It's pretty cool. So what if I do? And what else can I do with this? What else can I do? Yo, puts X. I mean, I know this works, but I don't know why I just like seeing it. I just like making it go. Yo. So we only have one alloc A, and then we have a load and a load and a load. I guess it'd be kind of cool if it knew that it was already loaded, but yeah, I wonder how much optimization LLVM would do for me if I'd enabled some optimizations, which I know is a thing, but we'll save it for another video. I think this is good for now. I think this was really fun. I feel pretty good about that. Let's add all that to the index. There's only one other thing I wanted to do. I wanted to try, while I'm here, putting this namespace back, Natalie, and then replace Natalie with nothing. And then go down here and say, this is an LLVM value. And see, what else am I missing? So, VM value. Is that the only thing? Does this still work? Because that would save me a lot of typing. Yeah, we're going to go with that. Okay, so actually, I don't want to commit this, or this file I had to change because I'm on a different machine. So let's just do include and source and commit those. Add variables. Yeah, let's put a smiley right there. Boom. That's pretty cool. Hey, thanks for hanging out with me on this video. I hope you learned something. I know I did. I have the most fun sharing, learning new things and sharing them with you. That's the best way to learn, I think. So I hope that you have a side project you're working on, something that is pushing you to learn new and hard things, new and fun things. But I guess I'll see you in the next video. I'm going to try to keep working on this little LLVM backed compiler, even if it is like a throwaway toy, or maybe it'll turn into something someday. I don't know. But I have a few more days in this space where I can work on this. And so hopefully you'll check back in a later video and find out where it goes. But until then, see you next time. Bye.